So next we're going to look at normal distributions when using discrete data. So all the examples that we've seen so far have modeled continuous data. For example, number of grams of powder, number of hours that a light bulb would live, and so on. All of those have been continuous data, which is good because a normal distribution is a continuous model. But there are many situations where discrete data can also be modeled as a normal distribution. It's just going to take one extra step. So we'll go through an example and we will show how to do that extra step. So our example here is that a company produces boxes of candy. Okay, they are chocolate-coated pieces. The number of pieces in each box is assumed to be normally distributed, with a mean of 48 pieces and a standard deviation of 4.3 pieces. Quality control will reject any box with fewer than 44 pieces. Boxes with 55 or more pieces will result in excess cost to the company. What is the probability that a box selected at random contains exactly 50 pieces? Okay. So, it is normally distributed. So it is going to have that normal distribution curve. We know what mu is. Mu is 48 pieces, that's our mean. And we know that our standard deviation is 4.3. Okay. They want us to find that what's the probability of having exactly 50 pieces. So of x equaling 50. So the problem with that is that is a discrete number. Okay. So what we need to do is we need to turn it into a continuous variable. And the way we turn it into a continuous variable is we change it into the range of numbers that would round to 50. So if we think about numbers that would round to 50, 49.9, 49.8, 49.7, okay? And in fact, anything bigger than 49.5 would round up to 50. Okay, and if we think about all the numbers that would round down to 50, so 50.1 would round down to 50, 50.2, 50.3, all the way up to 50.5. So any decimal that you choose in this range, when you round it to the nearest whole number, so in other words, the nearest chocolate, it would get you to 50. This is known as continuity correction. And the way I'll represent it is I'll do a little CC above the equal sign to show that we are applying the continuity correction. Okay, or sometimes I'll do an arrow with a little CC to show continuity correction. So, whenever we are given a discrete variable and we want to model it using a normal distribution, which is a continuous function, we have to apply the continuity correction. Continuity correction converts a discrete number into a continuous range. Okay, and when we have it as a continuous range, then we're able to model it using our continuous normal distribution function. So, you always have to ask yourself, is it a continuous variable? If it is, you just go ahead like normal and find the z-score. If it's not, then you have to think, how would I convert this into a range of values that will round to the values that I want? So back to this example. Now we're just working with this probability of x being between 49.5 and 50.5. And from then on, we're just doing it like normal. Okay, so we're going to have to find two z-scores. The first z-score will be when the x is 49.5. And the second z-score will be when the x is 50.5. Okay, so we have our two z-scores, which we're going to have to look up in a z-score table. And then we are going to do the probability that x is less than 50.5, so that's the value that we get from our second z-score, which is 0.7190. minus the probability that x is less than 49.5, which is the value we got from our first z-score, which is 0.6368. And if we do that subtraction, we get 0.082, which really means that the probability of exactly 50 chocolates is 8.2%. Okay, so for part B, it's asking us what percentage of the production will be rejected by quality control as containing too few pieces. So, too few pieces would mean that there are fewer than 44 pieces. So that would be the probability that x is less than 44. And since it's a discrete variable, we do have to apply continuity correction. And we have to think what values would round to numbers less than 44. So 44.1 wouldn't. So it needs to be less than 44. So 44.9 would round, 43.9 would round up to 44, which we don't want. 43.8 would round up to 44, which we don't want. 43.7 would round up. 43.5 would round up. So we want it to be less than 43.5. Because if you take any number less than 43.5, it's going to round to 43 or below. Okay, so that's applying that continuity correction. Okay, so now we just have to find the z-score. 43.5 minus 48, which is our mu, over our standard deviation. We get a z-score of negative 1.05. And if you look that up in the table, you will get that the probability is 14.69%. So there's a 14.69% of rejection due to having too few pieces. So remember, just for continuity correction, always check and make sure that the numbers you have round to the values that you actually want. So here, for instance, we wanted it to be less than 44, so the closest would be 43 and below. So we started with values that would round to 43, and we went less than that. So here is our next one. Each filling machine produces 130,000 boxes per shift. How many of these will lie in the acceptable range? Okay. So back in the question, it said that they would reject boxes that had fewer than 44. So we need 44 and above for it to be accepted. So that's why I did greater than or equal to 44. And they will also reject any box that has more than 55 or equal to 55. So that's why we had a strictly less than. Okay, so now we need to figure out continuity correction here, because these still are discrete values. We need to turn it into their decimal equivalents. So if we think all the numbers that would round to 44 is going to be 43.5 and above. Okay. And then if we think about all the numbers that will round to something less than 55, that's going to be 54.5. Because anything less than 54.5 is going to round to 54 or below. So just like before, we're going to do the probability that x is less than 54.5 minus the probability that x is less than 43.5. And for each of these, you're going to calculate the z-scores. And whether you put the actual values or the rounded values on your graph, it doesn't really matter to me. Okay, so take a minute, calculate the two z-scores, and find the probability. So there's our two z-scores, and if you look up the first z-score in the table, you would get that the probability is 0.9345. And if you look up this second z-score of negative 1.05 in the table, you get that it's 14.69%, which we already had in a previous question. Okay. And we get the chances of them being in the acceptable range as 78.76%. Now, it's not actually asking us what the percentage is, it's saying how many of the 130,000 boxes will be in the acceptable range. So we need to actually calculate that by taking the 130,000 boxes and multiplying it by the probability that it will be in the acceptable range. And we get 102,388. Okay, so 102,388 will lie in the acceptable range. So the next question says, if you own this company, what conclusion might you reach? If we think about it, 78.8% essentially are within the acceptable range, but that means that there's an awful lot of waste. So I would say based on those probabilities, there's too many rejects. The last thing for you to do here is I've given you some probabilities with discrete values. I want you guys to practice coming up with the equivalent continuous range. So I want you guys to do the continuity correction. So pause the video, and then when you unpause it, you'll get the answers. And there are your answers. Okay, so give the homework a try, and please email your teacher if you have any questions at all.